There are no national electrical code or other code minimum height requirements for receptacle outlets installed in the wall of a garage. The only code requirement for receptacle outlets in garages is found in Article 406.3d. This article states that in garages, at least one receptacle outlet shall be installed on each wall or partition. The code does not specify a minimum height for these outlets. It is important to understand what a receptacle is. A receptacle is a contact device installed at the outlet for the connection of an attachment plug. A single receptacle is a single contact device with no other contact device on the same yoke or strap. A multiple receptacle is two or more contact devices on the same yoke or strap. An outlet is a point in the wiring system at which current is taken to supply utilization equipment. Receptacle outlets are the outlets where receptacles are installed. The National Electrical Code, or NEC, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is not law unless adopted by a state or local jurisdiction. It is updated every 3 years. The NEC contains requirements for various aspects of electrical installations, including wiring methods, overcurrent protection, grounding, and equipment installation. Article 406 specifically addresses receptacles, cord connectors, and attachment plugs, covering their installation, ratings, and required features. Article 406.3 pertains to the installation of receptacles. Subsection D focuses on receptacle requirements in specific locations, including garages. The requirement in Article 406.3d for at least one receptacle outlet on each wall or partition in a garage ensures that there are readily available power sources for tools, equipment, and other electrical devices commonly used in garages. The absence of a specified minimum height for these receptacle outlets provides flexibility in installation, allowing electricians and homeowners to position the outlets at a convenient height based on the specific needs and layout of the garage. It is important to note that while the NEC does not mandate a minimum height, other considerations may influence the placement of receptacle outlets in garages. Firstly, accessibility. Receptacle outlets should be installed at a height that is easily accessible for users, taking into account factors such as mobility and the types of equipment that will be plugged in. Secondly, safety. Receptacle outlets should be positioned in a location where they are not likely to be damaged by vehicles or other objects. They should also be protected from moisture and other environmental factors. Thirdly, convenience. Receptacle outlets should be placed in locations that are convenient for the intended use of the garage, such as near workbenches or parking areas. It is also important to follow all other applicable NEC requirements when installing receptacle outlets in garages, such as those related to grounding, overcurrent protection, and wiring methods. Garages are considered damp or wet locations, so ground fault circuit interrupter, or GFCI, protection is typically required for all 125 volt, 50 amp and 20 amp receptacles. GFCI protection is a safety measure that helps to prevent electrical shock. It works by monitoring the current flowing through a circuit and quickly disconnecting the power if it detects a leakage current. Leakage current can occur when electricity flows through an unintended path, such as through a person's body. GFCIs are designed to trip quickly enough to prevent serious injury or death. They are typically required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. The specific requirements for GFCI protection can be found in Article 210.8 of the NEC. In addition to GFCI protection, other safety measures should be taken when installing receptacle outlets in garages. These include using weather-resistant receptacles if the location is exposed to the elements and ensuring that all wiring is properly grounded. The NEC also includes requirements for the type of wiring that can be used in garages. For example, non-metallic sheathed cable, or an M cable, is generally permitted in dry locations, but it is not permitted in damp or wet locations. In these locations, other types of wiring, such as rigid metal conduit, or RMC, or electrical metallic tubing, or EMT, must be used. It is always best to consult with a qualified electrician to ensure that all electrical work is performed in accordance with the NEC and other applicable codes. Electricians have the knowledge and experience to safely and correctly install electrical wiring and equipment. They can also help to identify and correct any potential electrical hazards. When planning the electrical layout of a garage, it is important to consider the present and future needs. This includes determining the number of receptacle outlets that will be required, as well as their location and height. It is also important to consider the types of equipment that will be used in the garage and to ensure that the electrical system is adequate to handle the load. Overloading electrical circuits can be dangerous and can lead to fires. It is important to ensure that the electrical system is properly sized for the intended use. The size of an electrical circuit is determined by the amperage rating of the circuit breaker or fuse that protects it. The amperage rating of a circuit breaker or fuse indicates the maximum amount of current that the circuit can safely carry. Exceeding the amperage rating of a circuit can cause the circuit breaker or fuse to trip, interrupting the flow of electricity. Repeatedly tripping a circuit breaker or fuse is a sign that the circuit is overloaded and needs to be upgraded. The NEC provides guidance on how to calculate the load on an electrical circuit. The load calculation takes into account the wattage of all of the devices that will be connected to the circuit. The NEC also provides tables that list the ampacity of different types of conductors. The ampacity of a conductor is the maximum amount of current that it can safely carry. It is important to select conductors that are large enough to handle the load on the circuit. Using undersized conductors can cause them to overheat, which can lead to fires. In addition to receptacle outlets, garages may also require lighting outlets. The NEC requires that garages have at least one lighting outlet installed in each vehicle bay and at least one lighting outlet installed in the exterior of the garage. The lighting outlets in the vehicle bays should be located so that they provide adequate illumination for working on vehicles. The exterior lighting outlet should be located so that it provides adequate illumination for entering and exiting the garage. The NEC also includes requirements for the type of lighting fixtures that can be used in garages. For example, lighting fixtures installed in damp or wet locations must be rated for those conditions. It is also important to ensure that lighting fixtures are properly grounded. Garages can be a hazardous environment, so it is important to take precautions to prevent electrical shock and other electrical hazards. By following the NEC and other applicable codes, it is possible to create a safe and functional electrical system in a garage. The absence of a minimum height requirement for garage receptacles, as clarified by the NEC, allows for customized installations based on specific needs and garage layouts. Remember to always prioritize safety and adhere to all applicable electrical codes. When working with electrical systems, always disconnect the power supply before beginning any work. Use appropriate safety equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician. The electrical work can be dangerous and should only be performed by those who are properly trained and equipped. Ensure all work complies with local and national electrical codes. Regular inspection and maintenance of the electrical system can help to identify and correct any potential problems before they become serious hazards. If you notice any signs of electrical problems, such as flickering lights, sparking outlets, or tripped circuit breakers, have the system inspected by a qualified electrician. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock. Ensure that all electrical equipment is properly grounded and that the grounding system is properly maintained. Surge protection can help to protect electrical equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other electrical disturbances. Surge protectors are designed to divert excess voltage away from electrical equipment, protecting it from damage. It is important to choose surge protectors that are rated for the specific equipment that they will be protecting. Tamper-resistant receptacles, or TRRs, are designed to prevent children from inserting objects into the receptacle slots. TRR have internal shutters that block access to the slots unless both prongs of a plug are inserted simultaneously. TRR are required in many new construction and renovation projects. Arcful circuit interrupters, or SIs, are designed to protect against fires caused by electrical arcs. Electrical arcs can occur when there is a break in the insulation of a wire or when there is a loose connection. SIs are designed to detect electrical arcs and quickly disconnect the power, preventing a fire from starting. SIs are required in many new construction and renovation projects. Always use the correct size and type of wire for the application. The size of the wire is determined by the amount of current that it will be carrying. The type of wire is determined by the environment in which it will be installed. Using undersized or inappropriate wire can be dangerous and can lead to fires. Ensure that all electrical connections are tight and secure. Loose connections can cause overheating, which can lead to fires. Use appropriate connectors for the type of wire being used. Do not overload electrical outlets or circuits. Overloading can cause overheating, which can lead to fires. Use power strips with built-in circuit breakers to protect against overloading. Keep electrical cords away from water and other liquids. Water and other liquids can conduct electricity and can cause electrical shock. Do not run electrical cords under rugs or carpets. Running cords under rugs or carpets can damage the insulation and can create a fire hazard. Inspect electrical cords regularly for damage. Damaged cords should be replaced immediately. Do not attempt to repair electrical cords yourself. Have damaged cords repaired by a qualified electrician. Be aware of the location of overhead power lines. Contact with overhead power lines can be fatal. Keep ladders, antennas, and other objects away from overhead power lines. Call before you dig. Before digging, call your local utility company to locate underground utilities. Digging into underground utilities can be dangerous and can cause power outages. Know what to do in case of an electrical emergency. If someone is being shocked, do not touch them. Disconnect the power supply immediately. Call emergency services. If there is an electrical fire, do not use water to extinguish it. Use a fire extinguisher that is rated for electrical fires. Evacuate the building immediately. Always consult a qualified electrician for any electrical work. Electrical work can be dangerous and should only be performed by those who are properly trained and equipped. The information provided in this narration is for informational purposes only and should not be considered as professional advice. Always consult with a qualified professional for any specific questions or concerns.